Hi, folks. Mr. Pollock here to help you out with transforming some quadratic equations. So to start us off here, we're going to start by going to desmos.com, as you can see right up here on the top. Great graphing tool I want you guys to utilize in class. Makes things a lot easier for all the graphing things we're doing. And so once you're there, you're just going to hit Start Graphing. So when we're talking about quadratic functions in the transforming, we're going to start with what we call our parent graph. Some people like to call it the mother function. I'm going to call it the parent graph for now. So we're going to type that equation in. So that's y equals x squared. There you go. And I'm going to keep this graph on here so we can see how the graph we're going to be moving in a second here is going to relate to this parent graph. So I'm going to keep it here, and I'm actually going to change it here really quick. So instead of red, going to settings here, I'm going to make it black just so it's a little bit darker than the other ones. There we go. All right. So first of all, before we get into graphing our equation, we want to point out some key points to our graph. The first point that we have to focus on is, and really the only key point we're going to focus on is what we call our locator point, which in my parent graph is located right there. Okay, right there at 0, 0. Okay, and this is the point we're going to focus on as we're comparing it and we're transforming this graph in a second here. Okay, and what's going to happen is you're going to see how the graph's going to change from our parent graph. All right, so let's type in this equation. I think we're ready for it. All right, let's see what we got here. So we're going to type our equation. So we have y equals a parentheses x minus h close parentheses squared and plus k. All right. So now once you type in the general equation, it says add sliders. So we're going to hit, instead of clicking one by one, we're going to add sliders to all of these. So we're going to hit all. And then you can see there the graph came. Woohoo! And when you're thinking about sliders, you're probably asking, what is a slider? First of all, these sliders, I know you're thinking like you want to go to White Castle and get some sliders right now, but that's not what we're talking about in this case. So what sliders are is they're basically going to plug in a whole bunch of different values for our parent function, for our graph here, okay, for our vertex form. So looking at this, you can see here that my vertex now, instead of at 0, 0, as you see here, it's now going to be at 1, 1, as you see there. So let's see what this equation of this blue graph actually is. Okay, so if I look at that, let's see what these things actually mean. So I have y equals, as you can see, I'm not very good here with this mouse. All right, and then my a value is really just 1. Typically, we don't write that because we assume 1 is there, but we're just going to type the 1 in anyway. So we got 1 parentheses x, which is our other variable, okay? And now my h value is 1, so it's going to be minus 1, close parentheses, squared. Okay, so that just stayed because it made my graph a parabola with the squared there. And then my k value, as you can see, is 1. So it's really going to be plus 1. Okay, so as you can see there, that's going to be exactly what these values are. So that's going to be my blue graph. So what we're going to do in a second here is we're actually going to change these parameters. Okay, so let's try that. Okay, and so what we're going to do while we're doing that is we're going to, wait for it, make that parabola dance. Okay, all right, you got my dance move for the day. All right, so now let's take a look at the a value first. Okay, so what we're going to do is we're going to take a look at this a value, and let's see what happens when we change that value. So as a gets larger, well, first of all, before we do that, let's move h and k actually. So it's back at the parent function, locator point. So 0 and 0. Good. So now we just got 1x squared. As you can see, it's the exact same as the parent graph. So now when a is greater than 1, let's see what happens. So, whoa, it gets really skinny. All right. And as we move it, okay, so, it's flattening out. There we go, getting less than 1. And then what happens when we go negative? Whoop! There you go. It flips the other side of the graph. So again, there's the positive, whoop, and negative. Positive, negative, positive, negative. Now you see why I like to make this graph dance. Okay, so let's sum this up really quick. Okay, well, a equals 0. What happened? As you can see there, it's just going to be a completely horizontal line because it's really just y equals 0, because anything times 0 is 0. So that's all we have left, in case you were wondering. All right, so let's look at the special situations here from the parent graph. So here I am when a equals 1. It's the same as my parent graph. So when a is greater than 1, things you might want to jot down. Heck, let's do it. Okay, so if a, okay, you can listen to me instead of looking at what I'm writing. If it's greater than 1, as you see here, the graph is going to be really skinny. All right. Okay. Now let's look at another situation. What's going to happen when A is going to be between 0 and 1? So as you can see here, there I am right back on it. And now when it fattens out here, as I like to call it, okay, the A value is less than 1. So again, A value is, so A is less than 1. And also A has to be greater than 0. There we go. You can see the graph's going to be wider, okay, or fatter, as I like to call it. Another way to look at it, we can also use the term vertically compressed, as you can see. Think about like you have a rubber band and you squish it together, okay? That's going to make it compressed. In other words, a little bit wider, okay? And let's look at the last situation here. So that's going to be when A was less than 0. So when it goes negative, and then it goes whoop, helping me with our dance here, okay? So anytime it's negative, what we're going to focus on there. So to describe a negative number, that'd be A is less than 0, okay? That's going to make the graph flip. In other words, it's going to open upside down, okay? In a more technical term, if you're ready for it, is reflecting over the x-axis, all right? So as you can see, A has a lot of those nice transformations with it, all right? So let's move that back to the parent graph now. So let's move A back to 1. And there it is. Okay, so let's see what happens when we have H and K. So what do you think H is going to do to the graph? So when I move it, as H gets larger, moves it to the right. As H gets smaller, moves it to the left. And I want you to point out one key thing here. So let's say H was -3, okay? What is this equation actually going to look like? So when I write this equation, it's actually y equals A, which is just 1, so I'm not going to write that there. So we got parentheses, x. Now it's minus, and the value we actually put in, remember when we substitute a value in, we always put in parentheses. So it's x minus the quantity -3, like my great penmanship here, okay, squared, and then obviously we have no k value, all right? So we're actually subtracting -3. So what you're used to seeing when we simplify this is the equation y equals, and it's going to be the quantity x. Now you're going to think about here what do two negatives make, and that's going to be a positive. So it's x plus 3 quantity squared. Okay, so you see when we have that, it's actually moving the graph 3 units to the left. So 1, 2, 3 units to the left. Hence you see the locator point right there and the locator point right there from the parent graph. Okay, so again, 1, 2, 3 to the left as you see. So H is a little tricky with that, so you got to be a little careful with that one. All right, and let's look lastly. So H again moved it horizontally. So let's go back to that parent function. There it is. Okay, and let's move K. So when we take K, where do you think that's going to move the graph? So as K gets larger, it's going to move the graph up. And as K gets lower, it's going to move the graph down. Simple as that. So simply just what we call a vertical shift. Okay, it's just shifting that graph vertically up and down. It's pretty sweet like that. All right. So let's sum it up right now, and let's see how good you're at you're good at this. All right, so now let's bring it back together. So now we have the situation, as you can see, with my great penmanship I have here. I want to see how are we going to take this graph. So we want to do 4 transformations. So we want to move it to the right 3. We want to move it up 2. We want to flip it, or more technically reflect it over the x-axis. And we also want to make it skinny. In other words, vertically stretched. Okay, is a more technical term for that. Okay, so let's see how we're going to do this. So what we're going to do is, again, you're looking at our parent graph right here. So as you can see, we're focusing on this locator point. Let me just point that out for you again. So there's my locator point. Bam. All right, and let's see what's going to happen. How are we going to move this graph to the right 3? So as you saw, I'm going to go to my H value because it's a horizontal shift. If I want to move to the right 3, okay, if I do like x minus -3, as you see there, that's moving it to the left 3. That's not what we want, because this would really be x plus 3 squared. So if I move it to the right 3, I want H to be +3. So bam, there we go. So we just went right 3. Now we want to move it up 2. So to move it up 2, as you saw before, we're going to use our k value. So I'm going to move k to +2. Okay, a little too far. There we go. So k is now at +2. And as you can see, my locator point is now at, bam, 3, 2. So I went right 3, as you can see there, and up 2. Okay, and then to reflect it, I'm going to go to my A value now, and I'm going to make it flip, so it's going to make it negative. And I want it skinny, so I'm going to make it any value less than 1. Okay, and as you can see, there would be my graph.